topic of this video is from Unit 3C on probability trees. We can represent an experiment that happens in stages with a tree diagram whose branches represent the outcomes of the experiment. The probability of an outcome is calculated by multiplying the probabilities found along the branches representing that outcome. These are called probability trees. Now, here is one example of what a probability tree looks like. For the first stage, outcome X has a probability of 0.3 occurring, and outcome Y has a probability of 0.7 occurring. So this is your first stage here and here. Either outcome X or outcome Y is going to happen at the start. A 0.3 probability for X happening, a 0.7 probability for Y happening. That's your first stage. Now these branches here represent the second stage. Now for this second stage, given that outcome X has already occurred, outcome A has a probability of 0.25 of occurring. Outcome B has a probability of 0.75 occurring. Also for the second stage, if we know that outcome Y has occurred, then outcome A has a 0.4 probability of occurring, and outcome B has a probability of 0.6 occurring. Now let's use this same probability tree to answer some questions about probability. So first of all, for this first question, this is asking you to find the probability of the intersection of two events. So whenever you're asked to find the probability of the intersection of two events from a probability tree, you want to follow the path from left to right on the two events. So starting here at the beginning, we're going to follow the path for Y and then for A. Those outcomes of Y and A. Now the probability for Y intersect A is just going to be the product of the probabilities that you find along the branches. So 0.70 probability for Y and then a 0.40 probability for A, given that Y has already occurred. So multiplying these two together, we get a probability of 0.28. Now we're going to find the probability of event B, given that event Y has already occurred. Now this is a conditional probability, so we know that event Y has already occurred. So the probability of it occurring does not influence the probability of B, because we know that event Y or outcome Y has already occurred. So follow the path on your tree diagram for outcome Y, but then when you get to your next outcome, follow the path for outcome B. That will be a probability of 0.6. So there's nothing to multiply here. We just have a probability of 0.60. Now let's find the probability of of outcome A. So looking at your tree diagram, outcome A occurs here, but it also occurs here. So we need to follow the path from start to finish and find the probabilities along each path. So for the top path, to get to A, we have a probability of 0.30 multiplied by 0.25. Then we're going to add that to the probability of 0.70 multiplied by 0.40. That's the path along the bottom to get outcome A. So multiplying, we get 0.075 plus 0.28, and adding those two probabilities together, we get 0.355.